So let's take an integral of another trig function. Our function is a function of time, t anyway. So f of t is a cosine omega t. That thing that looks like a W is probably a Greek letter omega, lowercase omega, and that's a constant, and the a is also a constant. So the only variable here really is time, t, and it's a trig. So instead of having polynomial rules, we'll have the rules for trig functions, and we're taking the integral. So the integral of f of t dt is going to be the integral of a times cosine of omega t, and that's with respect to time. And the a is a constant, so that can come out of the integral, and then the integral is just cosine of omega t. And the integral is with respect to time, so there we go, with respect to t. So how do we do that? We have an a, and then we're taking the integral of cosine of omega t. The integral of the cosine turns into a sine, so that's going to be sine of, the argument is omega times time. And then we have to take a derivative with respect to time of the argument of that cosine function, and we're going to divide by the derivative of that argument. So if we wanted to take the derivative with respect to time of omega t, which is really omega times t to the 1, then that would be equal to, we would take the 1 out front, so 1 times omega is just omega, and then t to the 1, the derivative of that, the exponent turns into a 1 minus 1 is 0, we get t to the 0, and that's just 1. So the derivative with respect to t of omega times t is just omega. So now we can finish our integral. We're going to divide by the omega, the derivative of that argument. And that's it for that term, but of course there's a constant of integration that comes out front. So in fact, that's our answer.